We're starting to roll in. Welcome, everyone. We're expecting a good crowd for today's session. So I'm going to give it a few more seconds. In the meantime, while we're waiting for people to get into the session, again, apologies for those of you who have been attending all of these sessions because I keep repeating myself. Please make sure you have your first and last name listed in the participant list. It's helpful for me when I'm reporting CEU credits. That's how I know who's here and who's not. Sometimes you might have just a first name. That's sometimes challenging. So make sure you have both first and last name in the participant list. If you don't know how to do that, you can hover over your name and it will give you the option to click on it and rename. If you cannot figure out how to do that, please just chat directly to me at the AIA Pittsburgh account. Just click on me and hit chat and let me know who you are and that you're here. And with that, I think we will get started for today. So I'd like to welcome, first up, Michael Bruner with Case Technologies, who is the sponsor of this session, Decarbonization, Understanding Operational and Embodied Carbon. So with that, Michael, you are up.
Great, thank you, Kiara. I appreciate it very much. Thank you for allowing us to sponsor today's event. Welcome to today's presentation. Like Kiara said, my name is Michael Bruner from Case Technologies. You know, we're a proud and longtime sponsor for AA Build Pittsburgh. We're happy to do so. I think it's probably been over 15 years somewhere in that neighborhood. So we're excited to be here today as well. And basically give you some insight from who Case Technologies is and what we do. Our primary focus is as an Autodesk reseller. So things like software as a solution. The game is changing with software these days for AutoCAD, Revit, cloud solutions. I'm sure you've heard of BIM Collaborate Pro or BIM 360 Design, some things that we get involved with. So that being said, we help your team work with those applications more in depth, implementation, support, training, things of that nature. So also, we are involved with Leica Geosystems. So one of the things we do as well is we get involved with scanning. So if you're familiar with scanning point clouds, capturing data, we do that as a service as well as sell the products to help you do it yourself as well. So if you had a large as-built project you were working on, you wanted to get that into either AutoCAD or Revit, we can help you put that together in a point cloud, capture the data with a scanner, bring it over to you as either a point cloud or an AutoCAD drawing or a Revit model. So some of these things to keep in mind that we can help you with as well. And some of the scanners we work with, if you're familiar with the technology a little bit, there's a BLK 360 and an RTC 360. Some of these scanners are pretty powerful technologies and they can get rather pricey, so they don't let me touch them. So I'm just allowed to talk about them really, quite frankly. So that being said, also one of the things we worked on with our team member, Mark Dietrich, who a lot of you are familiar with here from at Case Technologies. He's our Director of Services. We've spent the past, I think it's about 3 years now, working on in Volterra, Italy. It's a 3,000-year-old Etruscan village. We basically scanned, remodeled, and brought it back to life in a sense. So we're capturing that data. And if anybody has any interest in ever working on that project with our team, reach out to Mark Dietrich. He'd be happy to share that data with you. And if you go to our site at casetech.com, you'll find more about that as well. So also one of the things we also provide as Case Technologies, peripheral support of your infrastructure, your hardware, Lenovo products, mobile station class workstation class desktops, things of that nature. So something to keep in mind for if you need help with that as well. So, and really, once again, we're here to partner with you to help you out. And lastly, one of the things we are proud of too, like I said, things are changing in this industry with SaaS or software as a service. So keep that in mind. If you have any questions about how that works with the cloud and things are changing the game, we'll be happy to let you know. Okay, so feel free to call, email. Any one of us are here to help you out. So thanks again. And thank you, and enjoy today's presentation. Thank you, Kiara.
Thank you, Michael. Can everyone hear me okay? Hope so. Aurora, Isaac, and Danny, I'm going to start with the audience polling instead, so I don't have to toggle back and forth between our presentation. So before we begin and tell you about ourselves, we wanted to ask you guys who you are. I'm going to launch a poll. So everyone should see this now with our first question. What is your role in the industry? So we're just really trying to gauge who's all here today. I'll give it some time before everyone answers. Okay, a few more seconds. Almost
Yeah,
everyone's
Jeopardy
in.
music playing. Step out of that.
We should have a playlist. Okay. Last call for an answer. All right, I'll end the poll and share the results, hopefully. Can everyone see the results?
Yes.
Not surprisingly, most people here today are architects, given that this is an AIA event. We have an interior designer, sustainability consultant, and 2 people who identified as another role in the industry. So if you want to share what your role is in the industry, feel free to use the chat so that we can learn a little bit more about everyone. Okay, so do the next poll question. There's no right or wrong answer, but we just want to know if you know the difference between operational and embodied carbon. So feel free to be honest. We just want to gauge everyone's understanding of the subject we're going to talk about today. Give it 5 more seconds. Okay. Out of everyone who answered, we have a little over half people who answered know what the difference is between the two. So that's great to see that. And for the other half that don't, by the end of this, you will know. Question number 3. We'd like to know if your company is a signatory to the AIA 2030 commitment. This is a yes, no, or not sure question. Within the presentation, we'll talk about what this commitment is a little bit if you're unfamiliar with it. So I'll give it 5 more seconds, hopefully get those answers in. Okay, I think that's everyone. Right, so we have a little over half of the participants today have said that your company is not a signatory to the AIA 2030 commitment, and 32% of people today are unsure. So that's interesting. We have a follow-up question for that one for those of you who have report or are AIA 2030 commitment signatories. We want to know if you've reported your projects to the AIA DDX, which is the Design Data Exchange. So probably not going to get as many answers for this. I'll give it a few more seconds though. Okay. Share the results here. It looks like of the people who are AIA 2030 commitments, we have a little over half that haven't submitted. So hopefully next year, if you haven't already submitted this past year, you can make that a goal for your company to submit. And then our last question before we start the presentation, we're just wondering how many of your projects have had embodied carbon assessments completed with a range of none to over 7. And if you're not sure, feel free to either skip this or say none. Okay, stop that and share the results. Okay, this probably doesn't surprise us too much, but almost everyone who responded said that none of their projects have had embodied carbon assessments completed. So hopefully, if we were to do this poll next year, we'd get some more answers on that. Okay, so I'm going to share my screen now and we'll start the actual presentation portion. Give me 1 second. Okay, do you guys see the presenter mode or the actual presentation?
We see presenter mode.
Well, that's unfortunate. Okay, give me 1 sec. Okay, how about now?
Good to go.
Perfect.
Okay, just heard my husband in the other room said good because he's in this presentation. Okay. All right, so our topic today is decarbonization, understanding operational and embodied carbon. We have 2 different companies coming together today to present this subject to you. So Aurora, if you want to start by introducing yourself.
Hi, everybody. I'm Aurora Jensen. I work at Bureau Happel Engineering. I'm a sustainability engineer, and I largely focus on modeling embodied carbon using life cycle assessment and operational carbon using energy modeling. Over to you, Isaac.
Thanks, Aurora. Hey, everyone. My name is Isaac Smith. I work for Bureau Happel as well as a sustainability consultant. I'm local here to Pittsburgh. I've been working on existing building infrastructure, city planning work for the last 8 or 10 years.
My name is Danny Diono. I'm the Net Zero Advocacy Manager at Branch Pattern, and I work with project teams to help set pretty aggressive sustainability goals, ideally net zero carbon, embodied or operational, and work really closely with Julia on a lot of our projects here.
And I'm Julia Waddick, a sustainable design consultant with Branch Pattern. I'm local here to Pittsburgh. I help clients envision and execute their sustainability goals on projects. Before we get really started, let's talk about the learning objectives for today. So by the end of this, hopefully you'll learn how to describe operational carbon and strategies for reduction. Similarly, we'd like you to be able to describe embodied carbon and those strategies for reduction, and then get to the point of being able to identify tools, data sets, workflows for examining both operational and embodied carbon. And then finally, you'll learn how these approaches have been used to drive reductions on our own past projects between Bureau Happel and Branch Pattern. So I'll hand it off to Isaac to give us some climate context.
Thanks, Julia. And what good presentation about carbon wouldn't start off with some doom and gloom, but I assure you throughout it will get happier. There will be some good takeaways. I think we're all aware of the situation we're in, a dire situation, if you will, in terms of needing to change in terms of design, operations of our buildings. We have the power as the A&E community. By 2060, we're essentially going to double the square footage of new construction building that we have currently in place. So that's a significant portion of built environment that we need to take into consideration. And we have the tools right now to change that path, whether that's through the design or the operation of our buildings. Next slide. So the climate emergency in terms of the building environment is really key. So the building and constructions account for 40% of all energy-related CO2 emissions. In order to meet these Paris climate agreements of 2%, 2 degrees Celsius, we really need to start constructing all new construction buildings to the highest efficiency standards and really using no CO2 emission in terms of fossil fuel and energy generation to operate. We have the power to design, operate, and select materials that are significantly or have significant impacts on how the overall global emissions pie looks. And where and what is driving this? It's coming from a couple different aspects. We have the public and political side with, the youth and climate marches, and many of us who are engaged politically. We're seeing this in the new administration with focus on energy infrastructure. We're seeing this with our clients demanding sustainability goals or high aspirations within their new construction projects. We're seeing it in the various industries, whether that's the architecture community, the engineering community, the client side, building operations. And then we're seeing it in the practitioners themselves. As architects, engineers, we've all committed to significant, in many cases, emission reduction goals through our practices. So this is being driven out of really 4 different corners. Back to you, Julia.
Awesome. So we're going to start by explaining some key concepts around carbon. So here, this graphic helps explain what embodied and operational carbon mean. On the left, you can see embodied carbon is really an inventory of emissions across the supply chain. So thinking beyond the emissions from that operational phase when we're running our buildings, embodied instead focuses on emissions from extraction of materials, manufacturing, transportation to site, installation of materials, as well as end-of-life processes like recycling and deconstruction. So it's really asking us to look at a larger scope of emissions than we've historically looked at and prioritized. On the right, operational carbon is really more traditionally linked to building energy consumption. And this is usually converting carbon from our fuel sources that we're consuming in a building, as well as pulling electricity from the grid. Looking at this at a sector scale, this begins to lay out where the emissions in the US are coming from, what's contributing. Transportation is a big chunk, as well as industry, but building materials and construction is considered 11% of this total, and building operations is about 28%. Now, 11% might seem small, but I think it's important to point out here that building operations is largely comprised of plug loads. So that's people charging their laptops, plugging in refrigerators and other high intensity equipment in their buildings. And there's only so far you can take reductions in plug loads. So to some extent, there's difficulty influencing that 28%. And as we get really efficient systems, we've done a lot of the work in the operational space already. And as we continue to advance that, we need to complement it with reductions on the embodied carbon side from materials and construction. When we mean carbon, we're actually talking about this unit that encapsulates many greenhouse gases. So this gives a picture of the difference in potency of many greenhouse gases that are included in our inventory. So for example, a unit of methane realized across the supply chain, say during construction, is going to be converted into its equivalent in carbon terms. So 28 units of methane, or sorry, 1 unit of methane is equivalent to 28 units in kilograms of CO2. So for that reason, carbon becomes our common accounting method across all greenhouse gases that might be included in this accounting. So now we're going to give you some idea about why you might care about this, some different ways of thinking about it from our two firms' perspectives. So timing is a really key reason to care about embodied carbon in particular. So if you think about all of the construction that's projected to take place in the next 30 years, and you aggregate the emissions associated with that new construction, this is what you see. So embodied carbon happens in a peak, kind of a potent spike at the beginning of a project in the first couple of years during construction. And then operational carbon accrues more slowly over the lifetime of the building. So if you aggregate impacts at the scale of our whole industry, you see that embodied carbon actually racks up more quickly because of that potent spike early on. So between now and 2030, 74% of the carbon realized in our industry is going to be embodied. And it's not until we get to 2050 that it starts to balance out between embodied and operational. They're both important, but I think timing is really important for embodied carbon in particular. Looking at the greenhouse gases of the US overall, this is an image from the US EPA, and it shows the different end uses on the left and then how those get translated into greenhouse gases on the right. If you then isolate which end uses are associated with operational carbon reductions, this is our typical approaches to improving our envelope, thinking about our chiller COPs, maybe switching to electric heat or something like that. These are the quantities of emissions we can influence as designers. This is sort of our full boundary. If you then layer on embodied carbon into your architectural practice and think about your material selections, your sphere of influence really grows. So you begin to influence decisions about transportation and supply chain that's bringing materials to your site. You're influencing iron and steel production or chemical processes or the cement industry. So it really grows that influence you have and allows you to have a totally different influence towards the parties you do business with up and down the supply chain.
Okay, another reason that you might care, or maybe you're starting to care about operational and embodied carbon and the need to reduce it, you've probably seen a lot of different commitments, reduction goals that have been made by various governments, nonprofits, private institutions. I even got something in the mail the other day that told me how much impact my bicycle has in terms of its carbon footprint. Another important challenge that we wanted to highlight that kind of it relates back to that poll question we asked you guys at the beginning is the 2030 challenge. This is asking all major renovations, developments, and new building construction to reduce their fossil fuel energy consumption to eventually become carbon neutral in terms of operational carbon by 2030. So we wanted to point out that whether or not your firm is aligning its goals with this challenge, we're past the point of asking buildings to reduce consumption by 70%. And as of 2020, we're at an 80% reduction rate. So these are some very lofty goals. It takes a lot of effort to get your building to carbon neutral, as some of you are probably familiar with. So what we wanted to pose as a question today, you can kind of reflect on through this presentation, is how are we doing? How is the AEC industry doing in terms of meeting goals like this to become carbon neutral by 2030? One way we can measure how we're doing is to analyze the building operation energy consumption use. So this chart is showing basically where the industry stood in terms of operational energy consumption in 2005 by that red dash line at the top. And that was the projected path if things did not change in 2005. Whereas the bottom green line you can see in 2016 is progress based on changes that have been made in order to reduce the amount of energy consumption that buildings are accountable for. So you can see in this equivalent diagram that it's basically the equivalent of over 1,200 coal-fired power plants. So some big progress to be made for sure, but still it's above any goal of being at carbon neutral by 2030. So why has this decrease in energy consumption happened? A big part of that is due to improved codes. Having more stringent energy codes has really made a drop in energy consumption in buildings, obviously. Additionally, shifting our energy grid from relying on coal to natural gas has even helped, but even more so, relying on renewable energy production makes a big difference. The question that we're asking again is how much is this due to design? And if it's not as likely that design has been making this kind of impact on energy consumption, what can we do in the next 10, 20 years to get our energy consumption to zero or even be positive energy production? Another challenge, shifting away from operational carbon to embodied carbon. The 2030 challenge for embodied carbon was introduced by Architecture 2030. And this challenge spawned the Carbon Leadership Forum, which some of you might be familiar with. Side plug, if you're interested in getting involved, we do have a chapter here in Pittsburgh, so we can set you up with the right person. This challenge asks that building reduce embodied carbon emissions to become zero by 2040, so a little bit more time. But as you can see, there's still incremental thresholds to design to. Today would be a 40% reduction. And this might just seem like numbers on a graph, so it can be a little overwhelming, wondering how are we going to get to zero carbon emissions? And that's what we're hoping to talk about today, ways that you can do that on your own projects. It's not just going to happen magically. We really have to make an effort to get there.
Awesome. Okay, the other part of why you should care is really about carbon reporting. And so I'm going to go through this a little bit quickly. Hopefully you've heard of ESG reporting. So right now we're at a point where 86% of companies in the S&P 500 publish an ESG report and make that public. These are your clients. If you have corporate clients, they are likely responsible for creating an ESG report. That stands for environmental, social, and governance. And your clients will likely be asking your help and making these reports, collecting the data, but then showing some sort of reduction. How does that relate to buildings? So let's dial in on the environmental reporting and talk about these three scopes. The first scope is direct greenhouse gas emissions that come from a company's own environmental emissions associated with buildings, so fuel combustion, and their own company vehicles. This is probably the biggest impact we as the design community have for our clients to reduce their greenhouse gas emissions. we've been contacted by clients, I'm sure a lot of you have as well, asking them for data. How much greenhouse gas emissions am I emitting through my buildings? And how do I reduce it? And so that's really what we're going to try to help them solve to improve these reports. The second scope is indirect greenhouse gas emissions, and that's associated with the actual power plants where they're purchasing electricity, steam, heat, cooling. Power plants create greenhouse gases by combusting fuel and then transporting it to the actual building itself. That's a little bit harder to measure, but that's very, very connected to buildings as well. And then finally, we have scope 3 emissions. This includes 16 different categories that vary tremendously from the product chain, supply chain, all the way to business travel or commuting to work. But it does include materials, which does get into a little bit of embodied carbon. Really quickly, we just want to point out an example of BlackRock. So BlackRock is today carbon neutral for operations. You can see their 2020 goal and how they've made progress to date. They are a huge investment company. They want to invest money in other companies, but in order to do that, they're requiring those companies to do ESG reporting. So again, your clients, your corporate clients that want this type of investment are going to have to be doing this own reporting themselves. And this is just another example of their environmental indications and what they're actually measuring and showing that reduction from 2014 to 2019 and that percentage change. So expect your clients to start reaching out to you, asking for help on the building aspects, which again is scopes 1 and 2, and even a little bit of 3.
Thanks, Danny. I'm going to go ahead and lay some groundwork around operational carbon, doing some intros, and then we'll get a bit of a deeper dive into some tools and how to. So with that, first we need to understand kind of the grid context, where we're at, because it all plays a significant role in our operational carbon. You know, as we design and operate buildings, it's really important to understand the key calculation variables that we're dealing with as designers and engineers. You know, from the supply factors to where we're located and what sort of footprint our electric and natural gas supply has, to the various technologies that we're scoping and putting into our buildings. And then as designers and thinking about new construction, the interplay of those technologies and how they operate in our local climate and local context. So one of the first things to understand is the wholesale electric power markets and where we stand. So if you're all located in Pittsburgh, you're probably familiar with the PJM market. It's a 13-state interconnected generation market that is one of the largest, actually, of the markets in terms of how much power it emits. It actually effectively emits 21% of all the power and carbon dioxide emissions of all of the wholesale grids. Serves about 65 million people, and many reports and many calculations suggest that really the PJM is the linchpin, it's the bellwether, and if we're going to meet these decarbonization efforts in the United States, it needs to start with the PJM market. In 2019, the market itself was about 36% natural gas, about 34% nuclear, and 24% coal, and about 6% renewables. So this is something to keep an eye on as these generation sources change. It has impacts on our carbon story. Another kind of thing to be conscious of is the renewable portfolio standards. Now, each state, in many cases, have adopted standards that dictate how much renewable energy needs to be produced in that state. Now, Pennsylvania purchases a lot of renewable energy at the tune of about 30%, but this is purchased electricity, not necessarily state-run generated electricity. If we were to boil that down, it's about 5%. It comes from Pennsylvania state electricity driven. And there's escalation rates. So as we approach, 2020, 2021, I guess we're already in 2021, these continue to climb 8%, 9% for renewable portfolio. So this all has an impact on our calculations. So then how do we go about estimating it? First and foremost is understanding, the energy use itself. I'm sure we're all aware of, EUI as really the method for measurement. It's how we report buildings, it's how we track them, it's how we, report to LEED and AIA, but it's understanding our total annual energy use in that building divided by our total square foot to get a square foot energy use per square foot measure. typically how we think about this is, our site energy or energy use is fed into, lead models and Energy Star, and that's how we think about energy use. But we need to start shifting and really going the next step further to think about carbon. And how we're doing that as designers and engineers is we're looking at new construction buildings and we're designing them differently. We're doing energy modeling, we're doing daylight modeling, we're doing computational fluid dynamics to really understand how our buildings are being set up for success and how we can have an impact on those operational carbon. It all starts, with how we design, and that location has a significant impact. So if you're not doing this already on your buildings, we should be doing climate analysis, thinking about how the sun has an impact on our solar gains, directional, wind directional, this heat, humidity, this all has an impact on our buildings and how we design. Again, this goes into our passive strategies around natural ventilation. We can harness a lot of these passive strategies such as wind to do natural ventilation and reduce the sizing of our systems. If we take advantage of all of our passive strategies, this really allows us to do smaller mechanical systems. In the end, if we're able to right size our mechanical systems, we have a significant impact on reducing our overall energy use and therefore our operational carbon. So as an engineer, as designers, we're doing schematic studies of these systems. So once we start to put all of our impacts, we do our climate analysis, we're looking at our building orientation, we start to think about systems, right? Our passive strategies are in place. Now we need to understand how we're getting our systems. So whether that's, a VRF with heat recovery or water source heat pumps or active chilled beams, these systems play a role, and you'll see that in the graph on the right in the different system configurations. Then once we get, right size our systems and figure out what system makes the most sense, we can start to identify our overall annual energy operational energy. But then a lot of people stop at that point, right? So what we need to do as designers, architects, engineers is take it to the next step and turn that into operational carbon. This is where we can really see some of these end uses change in terms of our impact, where we might see in our energy use, for example, space cooling might be the largest. When we start to look at our operational carbon, some of those buckets change. So this is an important step to take advantage of. And then this plays out, we have all of our outputs from our energy model and we can feed that back into our grid, right? So we understand our context for our grid, where our generation sources are coming from. This example is from Virginia, but for those of you in Pittsburgh, this is pretty close to what we see in terms of our grid mix with natural gas, nuclear, and coal, and an increasing amount of renewables. And then this dictates what our overall operational carbon is by building end use. So what is the pathway for decarbonization, right? Just as a summary to what I just talked about, we need to design low energy use intensity buildings, right? This all starts with doing the proper analysis, climate analysis, taking advantage of passive design strategies. And then we take the next step and we start to electrify our mechanical system. While the grid mix might be different in your area with renewable portfolio standards and increasing renewables and decreasing and changing our fuel mix, electrification is the way to go. And as Aurora mentioned, where we can reduce our plug loads, it has a significant impact on our buildings. And then lastly, to get us the rest of the way is really the operational offset of carbon through our on-site renewables. And I'll turn it over.
Thank you, Isaac. Okay, so you might be asking yourself, what kind of tools are available to analyze operational energy use and carbon? Full disclosure, I am not an energy modeler. We have people at Branch Pattern who do that, and that's their specialty, and same with at Burrow Happold. So I just wanted to highlight that there's a bunch of different tools available and out there that energy modelers can use to analyze operational carbon and energy use. I was going to walk you guys through today the Zero tool, which I'll point out is a tool that's free, it's online, it directly supports the AIA DDX reporting platform. This is a great tool for establishing your baseline. So when Isaac was talking about your energy use intensity, you might be wondering, how do I even get started to understand that? This tool is a good way to help you understand what your building is consuming. So the first step is give your building a name, then the location. Based on the location of your building, it will auto-populate the degree days. So you no need to look that up, but any of this information is able to be overridden if needed. And then you basically decide, is your building new construction or an existing building? And in terms of the AIA 2030 commitment, new construction is defined as more than 25% by cost or surface area of the building. So if it's not that, then it's an existing building. The next screen that you'll come to on the Zero tool is asking you your building use details. So you basically have two main choices, commercial or residential. And then once you select that, under this drop-down menu, add another use, you can select the use type. So you can see in this example, I chose office and restaurant under commercial, but then I toggled to residential to add multifamily housing to this imaginary building. Next, it'll ask you some details about those use types. So depending on what your use type is, the tool needs to know, based on square footage, what are weekly operating hours, for example, for an office, and how many workers, how many computers. This will default. As you can see, I checked the default value box. So if you have more specific information that you can override, this is the place to add it. Otherwise, use the default value for your baseline. Next, it will ask you what your energy reduction target. This might be based on a commitment that your firm has signed. It might be based on your client's needs. It could be based on your local code, ordinance, or energy stretch code. So you can either enter a % reduction, or the inverse of that is the zero score. So in this case, 20 is the % reduction I entered. If I were to pick zero score, I would enter 80. And then it wants to know, are you using the Zero tool for the 2030 challenge targets? I think this is just a data collection on their end. If you have an existing building, this is an optional data field that you can enter, and it wants to know what's your annual energy purchase. So this is based on your past year of building use. What is your utility bill telling you that you've used? So this is where you would enter that information, as many energy types as needed. Additionally, if you have an existing building, you can also enter the annual energy generated on site. I didn't add it here in this example, but that would also shift your energy intensity of your building. And then finally, you'll click this calculate baseline and target at the bottom, and that will take you to a screen like this. So you can see that it's telling me my target EUI is 53 based on a 20% reduction. That's all based on the info I put for location and use type and square footage of the building, as well as the energy consumption piece I put in. So I just wanted to highlight that my building is not meeting the target that I've set for myself. It has a 57 on the site EUI, but my target is 53. You can see that there's also info for your source EUI, and just wanted to point out the main difference between that is that your site EUI this is the standard EUI metric, and it's considering all the operations that are happening on your actual physical building on site, whereas your source EUI is considered to be a little bit more equitable, and it's considering everything that goes into making your building function, from the transportation, the amount of energy that's going into the grid, what type of energy, and so that's helping define that source EUI. Additionally, the Zero tool can give you an estimate on your greenhouse gas emissions, so that plays into the operational carbon piece, and you can see that this building is performing better than the target for greenhouse gas emissions. Then finally, you can hit print and have a PDF saved so that you can share this in a proposal or with your client. Use this to analyze your building against. Then I wanted to point out that if you have a portfolio of buildings, you can actually download an Excel sheet from the Zero tool, and then that way you don't have to toggle through every click. You can have a sheet that you then upload to the tool's website, and that makes it a little bit easier for you. This tool, like I mentioned, is directly related to the AIA DDX. So if you report to that, there's really no need to use this tool through the Zero tool website. You can go straight to the DDX website.
All right, we have less than 20 minutes and we haven't even gotten to embodied carbon yet. So we're gonna try to speed up a little bit here. I'm gonna go through a really quick case study. This is a Washington Elementary School, which is in Canyon City, Colorado. You can go to the next slide, Julia. So this is a rendering of what the school will look like. It is currently under construction. All right, let's go to the next slide. Quick project overview. This is an elementary school, ground up new construction, about 60,000 square feet. It is in rural Colorado. You can see in the top right map, that's the entire state of Colorado, and where this project is located is the little pin. Because of its rural location, it received a grant, which requires the school to get LEED Gold certification. But because of the location, it has a lot of difficulty getting points in sustainable sites and linkage and transportation. So the goal of the project team here was to really maximize our energy and atmosphere points. We used Cove Tool to predict energy consumption and carbon. But for future iterations and to really dial it in better, we used IESVE to look at every single mechanical system that we were looking at. Okay, so what we did was we compiled a report based on a baseline, which is VAB with reheat and DX cooling, and looked at 6 alternative mechanical systems that the school could install and how it affected the energy use intensity. So like Isaac mentioned, each system uses a different amount of energy for cooling, heating, lighting, equipment, fans, and hot water. And so you can see how they, how much energy is used for each part based on the mechanical system that was selected. These 3 in the middle is what the project team decided to focus on because it was the lowest consuming energy systems. And again, we're looking at EUI, which is kTBU per square foot. So just energy usage at this point. Then the team decided to look at utility costs per year and overlay this with LEED points. So the way you get 4 points is by selecting a system that's underneath that 4-point bar. Again, we really needed to maximize points here. So we were only considering systems that would get us 16 points. So underneath that 16-point bar, which led us to these 3 middle systems again. Now we're looking at simply electricity and gas. So we took all of those parts from the first chart, converted it into what is using electricity, what's using gas, to then convert it into carbon. So here we have the carbon amounts in based off of carbon emitted through kilowatt hours, which is electricity, that's the orange bar, and carbon emissions based on therms, which is natural gas, which is that yellow bar, with the totals there up above. So it overlays really nicely. The more energy you use, the more carbon you'll emit. But it's kind of nice to do this analysis, as Isaac said, which isn't often asked for. So the overall moral of the story and the outcome here was that the district selected Radiant Slab, which was the 2nd lowest operational carbon emitting system. Now this is based because of LEED points and utility costs. They didn't care about carbon. They didn't ask about carbon. They didn't even use the C word. So, but that's our goal as the consultant. That should be your goal as the designer. How do we lower carbon emissions using the owner's goals? So find out what their drivers are, whether it's cost or maintenance or LEED points, and capitalize on lowering carbon emissions.
Okay, now we're ready for embodied carbon. Earlier in the presentation, Aurora showed a slide similar to this, where we just wanted to have as a refresher that between building operations being 28% of global CO2 emissions and building materials and construction being 11%, that's almost 40% that buildings are to blame for global CO2 emissions. So that's a huge chunk. Additionally, if we look beyond the 11% that can be directly contributed to building materials and construction, there's a little bit of blurred lines that the building sector kind of reaches into. So somewhere between the 11% of the previous slide and this highlighted red 43%, including concrete, steel, aluminum in the industry sector, buildings really should be held accountable because the industry sector considers different things like equipment, construction, building finishes, concrete, steel, and aluminum. We can't directly say that this X percent is contributed to buildings versus trains or something like that. So just something to consider that it's more than 11%. So
Okay,
Danny.
so what we're seeing here is embodied carbon emissions and operational carbon emissions over the building's lifetime. And as Aurora mentioned in the beginning, when the building is constructed, you see this huge embodied carbon spike that stays relatively stagnant over the building's lifetime, except when it's renovated or there's equipment updates or replacements. So what we're looking at here is that operational carbon adds up over time. Every single day that that building is operating, you're adding carbon to the atmosphere. And so we see over the building's lifetime in 30 years, the operational carbon is probably going to outweigh the embodied carbon, but that at the very beginning, the embodied carbon is obviously the largest emitter. So another way of thinking about this in the next graph here is looking at every single year, how much carbon is emitted. So again, the door's open, it's ribbon cutting. That's a huge amount of embodied carbon that went into building that building. Every single year is this little blue bar. Why it's decreasing is that it's predicting that the grid gets cleaner. So as we add renewable energy and we make, we utilize some of these technologies to make our grids better, we electrify buildings, we depend less on fossil fuels. Every year, the idea is that you're emitting less carbon. So you might be consuming the same amount of energy. Your building might consume the same amount of energy year 1 and year 30, but because the grid is cleaner, that's why we're seeing this decrease year over year. And you can see really closely that hatched mark in the middle there is showing you a high performance building. So how much opportunity there really is to be considerate in designing high performance buildings and not just building to code. And then lastly, and this isn't in the graph, but there is embodied carbon spikes from maintenance and renovation. And then there's also an embodied carbon spike at the end of the building's life and what you do with that material. Okay, so where you are matters. And we used a hypothetical building. We put it in the EC3 tool. Aurora's going to go through this tool in a little bit more detail, but I highly recommend that all of you create portfolios and start using the tool tomorrow. What this is showing you is a building in Pittsburgh. So the embodied carbon is orange, the operational carbon is blue. You can see that Pittsburgh's grid is pretty dirty because the operational carbon emissions are really high. It ends up being way more than 50% of the total global warming potential in year 2050. However, if we put this building, exact same building in Seattle, which uses a lot of hydropower, look how much that changes in the operational carbon emissions. Now we're seeing that the biggest impact we can make is in embodied carbon because the grid is so clean. So the idea here is that as the grid gets cleaner and cleaner, there's going to be more of a focus on embodied carbon. That's our opportunity to really reduce global warming potential.
Okay, so you might be asking yourself, how do you measure embodied carbon? So I'm going to walk through quickly the stages of an LCA. And an LCA can be applied to an individual material or a whole building life cycle assessment, which is obviously more common for the architecture industry. So the 4 stages of the LCA process generally contain defining a scope and a goal. From that scope and goal, you want to have an inventory of the materials that make up your building. Then after that, you analyze the impact that those materials have. And then finally, you interpret the impact and see where you can reduce the building's impact. Overall, the life cycles assessment is asking the industry to ask themselves how the material is made and think about how it's part of a bigger system. So it's not just about the individual materials impact, but really the whole of a building. Each stage of the LCA is defined first with the product stage, A1 through 3. So this is considering how do the materials get supplied, how are they transported to a factory and then manufactured. This A1 through 3 stage contributes up to 70 to 80% of an embodied carbon impact on a project. So this is the most important stage by far. Next is the construction stage, A4 through 5. This considers not only how the materials are installed on site, but also the transportation that happens. Then we have the use stage, which not only is the use of the material, it also includes maintenance, repair, refurbishment, and replacement. So like Danny mentioned, it's not just one and done. You might have a concrete floor that needs replaced, or would it need replaced, I should say, as often as something like painting your walls. So that's all considered. Operational energy use and water use are optional, usually outside of an LCA scope, depending on your building's need of an assessment. And then we have the end of life stage that includes how the materials are deconstructed, and then the process that it takes to get those materials offsite and disposed of. Finally, the end of life cycle includes reuse, recovery, and recycling phases. So this is usually outside of a typical scope. A little bit easier way to digest this is to consider this infographic. So again, the product stage, material supply, manufacturing, then into construction, maintenance and repair, and building operations is what's included in that operation phase, again, with operational carbon being outside the typical scope of an LCA, and then end of life cycle. So cradle to grave is really that first product stage, that 70 to 80%. And then cradle to grave considers the entire life cycle. You might have heard the term cradle to cradle. That would mean if the material were to re-enter the cycle. And quickly, some more acronyms to be thrown your way. Just wanted to point out the difference between an HPD and an EPD and how that relates to an LCA. So an HPD really considers the materials impact on human health. An EPD is more like a life cycle assessment of a certain material. These are the same impact categories that are in the whole building life cycle assessment, with the greatest emphasis on decreasing the global warming potential, which is measured in the kilograms of CO2 equivalent. What's exciting about embodied carbon policy is that it's actually starting to take shape across the US. So you can see California already passed legislation and other states are starting to introduce it. So hopefully we'll see PA turn from light yellow to eventually gold in the coming years. All right, Aurora.
Awesome. Okay, so with the time remaining, we're just going to give a sense of the workflow you would typically use for embodied carbon analysis, and then a sense of the kinds of questions you can answer. So this sets up kind of a sample pathway through the different stages in design, starting with high-level massing comparisons, maybe a structural comparison looking at different structural bays, or analyzing envelopes. Like if you sketch out 2 different envelope constructions early on, you can likely estimate their embodied carbon in a really coarse way in schematic design or even concept. Then in early DD, you might really start to fold that into a whole building analysis and understand where kind of the hot spots are from the building scale. As you transition into CD and construction documents, you are really working on translating that into the specifications. So this is writing potentially requirements around your concrete mixes, sourcing specific materials from manufacturers that are doing better than their competitors. There's a whole range of tools that are starting to emerge to help you evaluate embodied carbon on your projects. This is a sense, this isn't comprehensive, and it's our general take on what's more and less detailed in the modeling process. So Beacon is a relatively coarse structural targeted tool that you can use right in Revit. In the middle here, we have EC3, Tally, the BOM LCA toolkit, and Athena, as well as OneClick, which largely do that whole building type of study. Some of these are compliant with LEED and Living Building Challenge. And then SEMA Pro on the far right is sort of the most detailed. And this is usually used in professional grade LCAs that often set up the data that actually underpins these tools in the middle. So EC3 is actually the one we're going to be talking about in the most detail. And this is because it's a huge database of available environmental product declarations, which give us specific impact information for products that we might be using in our buildings. This map begins to express how you might use different tools at different times in the design process. So on the left, you can see tools like Tally, OneClick, and Athena allow you to run targeted design option comparisons as well as that whole building analysis. And then at later stages of design, folding that study into something like EC3 can allow you to layer on the more specific product level data that can take that into construction and make sure that those reductions are realized on your building site at the end of the process. So here we're going to cover a couple of quick case studies around embodied carbon and design. So this is a sample of what it looks like to work in EC3. It's free, you can create an account, and it has a whole lot of EPDs available for you. And those data points represent both industry average data from, for example, like the National Ready Mix Concrete Association, as well as specific product data from a manufacturer like CEMEX. So if you see here, you have the environmental impacts available to you when you use a tool like EC3. EC3 is actually focused on global warming potential in particular. And then on the right, you can read the relative impacts of the various products from a producer like the National Ready Mix Concrete Association. Actually, that's aggregated generic data compared to CEMEX or Cal Portland. And you're able to observe this kind of range across the available products in that category. So you can see the very low ranking products are around 231 for National Ready Mix Concrete Association. Those are really low embodied carbon versus the very high products like 632. In that middle range between 25 to 75th percentile, that's where most of your products are likely to fall. You could use EC3 to set up something as simple as a product-to-product comparison. So this is an example of pulling a number of EPDs out of EC3 and using it to pick an insulation and to overlay that with healthy materials layers like the red list or the declare label. And this can help be a conversation with the client about how to specify that material. You might also investigate questions like how a renovation compares to a new building. So on a study we had done at Bureau Happold in the past, we were asking this question at concept. So when this decision hadn't been made yet, and we were able to show using, in this case, the BOM LCA toolkit and geometric data in Rhino, that the new building was more than 10 times the embodied carbon of the refurbishment plan. And this was using kind of coarse estimations of what quantities of materials are demolished in each case and what quantities of materials are new in each case. This is an example of a study at an academic campus. This gives a sense of the output from something like the BOM tool. And here we're looking at a campus building and you're able to see where in the building are these impacts taking place. You can see that it's largely the concrete with some contribution from the rebar, structural steel, and the timber members. This study was in fact a comparison. So it looked at a timber option for this building with that as the predominant structural member compared to 2 steel options with different kinds of concrete flooring, and then a fully concrete structural solution. And you can see here that the range of outcoming carbon intensities at the building scale vary widely between these options. So the timber option is almost half of the concrete options, with the steel options falling somewhere in between. These are labeled lightweight concrete because that's the topping on that steel deck. We've also run studies that are more focused on the envelope system. So this is looking at sensitivity for envelope materials. On the left, you can see how coatings influence your aluminum. In the middle, you can see how glazing is affected by the number of layers and whether there's generic or safety or tempered glass. And then on the right, you can see insulation. And I think here it's just staggering to see XPS is like 14 times more intensive than something like polyiso. Really clear takeaways for designers.
All right, so this is a lot of information. Again, we started doom and gloom, threw a lot at you. So we wanted to just give you a simple list for what you could actually do tomorrow. So use this EC3 tool. We've mentioned it a bunch. They want us to mention it to you even more. Create an account, specify low carbon concrete, start comparing materials and materials to other materials to select those lower carbon ones in your drawings. Design out XPS insulation like we just saw in Aurora's graph. That is no bueno for embodied carbon. So don't even use it. Electrify your mechanical systems. Start talking to owners about electrification and being independent from fossil fuels. Use LED lighting. It makes sense for your cost and for the environment. Design beyond code. So just because code says you should design to a specific energy use intensity, go beyond that. Challenge your design team. Again, use this EC3 tool, find other low carbon materials. Maybe just start with carpet. Just pick one material in your next building design to go lower in your carbon. And finally, collaborate early with your design team as well as the construction team. They're the ones bidding and creating the schedules. Get them involved in how they can help you lower your embodied carbon.
And then just lastly, how we can influence the actual industry. You know, we play a role not only as decision makers on our individual projects, but we can really push the industry moving forward. We've talked a lot about EPDs, but we need to ask more for. We need to ask our manufacturers for specs and EPDs, and they'll deliver on that. And then we need to take those EPDs and we need to put them in the EC3 tool. I swear we're not working for EC3, but it benefits us all in the end when we can do product to product comparisons. And really, as designers and engineers, we need to help owners set ambitious targets, whether those be, energy targets. And really, we need to move beyond energy and think about ambitious embodied carbon goals. And then lastly, we need to include some of this work in our specs and our project scope early on, whether that's building life cycle assessments or really, building performance modeling, energy modeling that really helps, put some of this into practice.
Okay, realize that we're at time and it's the end of the day, so I appreciate everyone staying on board. If you have questions, we can stick around. I don't know, Kiera, I'll leave it to you, or if there's questions in the chat, we can answer after.
We have a few minutes between now and our next session, so
Okay.
if there are any pressing questions, by all means, you can unmute yourselves or put them in the chat.
Thanks. Let's stop my share.
I have a question specifically about the timing of when that graph you showed when operational energy use kind of supersedes the embodied energy use. And then you also showed like the example of Pittsburgh versus Seattle. And, in Seattle, the grid kind of makes you inclined to focus more on the embodied energy than operational, versus like here in Pittsburgh, where maybe we need to tackle operational a little bit more just because of the energy sources that we're using for our grid. Is there any way to kind of know when that intersection happens, when you should start focusing more on embodied than operational? Or should you just always be focusing on both? Or
Did you want to answer that, Aurora?
I can take a quick stab and then you can come in, Danny.
Sure.
So I would say that you could do an early analysis in a project to get a sense of the grid region that you are situated in and how dirty that grid region is. But for something like electrification, part of the reason why it makes so much sense, regardless of your grid region, is because of the higher performance you can achieve on your equipment. So rather than like a 90% efficient boiler, you could have a COP of 4, which is equivalent to like 400% in your heat pump or something like that. So they're really just, electrification makes a lot of sense, really regardless of your context, because of those higher efficiencies you can achieve. As far as which matters more, I think because they sort of fall on different consultants or different folks in the design team. I mean, the mechanical selection is really the biggest driver in the operational side. And then that's complemented with the architectural picture of what the envelope looks like, how the internal portion of the building is designed to reduce solar gain and all of that. But the architects really have a huge influence over the embodied carbon as far as the envelope materials go. So I think if, rather than deciding which is more important, if the different consultants kind of in that room take responsibility for their piece of the puzzle, we could take it a really long way.
Yeah, and then I think using that, I mean, we just plugged in an imaginary building in the EC3 tool and did a full building analysis to spit out that graph pretty quickly. So you can actually link your Revit models right into the EC3 tool and start showing your clients when that overlap happens. And hopefully we'll see the grid change slowly over time here, or maybe a little faster.
great, thank you.
Okay, and I think that's all the questions, unfortunately, that we have time for. I want to thank all of our speakers for joining us today and lending your expertise, and also Case Technologies for sponsoring this session. Thank you, everybody. Take care.
Thank you.
Okay, thank you.
Thanks, everyone.